Okay, in this video, we're going to look at a fairly straightforward example of finding some partial derivatives for a function of two variables here. All right, so in order to actually find the derivatives, you don't necessarily have to use the definitions, but you have to kind of think about what the definitions are saying in order to think about how you might approach finding these derivatives. Okay, so up here, we've previously talked about the definition of the derivatives. This is connected back to, I forgot one thing on this one. Important, connected back to what you learned in Calc 1 about the limit, important part here, of the difference quotient. So change in output divided by change in input, remembering that this denominator is really x plus h minus x, but the x's cancel. So the important thing about that, though, is that when you think about these definitions, in this first definition of the partial derivative of f with respect to x, you might notice that the y part here stays the same in both the original function and this second part here, f of x plus h comma y and minus f of x y. So the y stays the same, y is being held constant, and x is what is being incremented. So x is what's being treated as a variable. So that gives you some insight into how you might actually find these partial derivatives. When I find a partial derivative of a function with respect to x, I'm treating x as the variable, and then the other variables, in this case y, are being held constant. So then you can go back and leverage all your derivative rules that you've learned from Calc 1 for finding derivatives of functions. When I find my partial derivative with respect to x, partial derivative of f with respect to x, remember that x is what's being treated as the variable, and then any other letters here would be being treated as constants. So some students have a very easy time making this leap to all these different letters. You're just treating some of them as variables and the rest as constants, and some students struggle with this a little bit more. But this is a really crucial skill for you to be able to do really anything else the rest of the course. So it is worth taking your time if you need some extra time with this. Don't be frustrated. It's just normal that some people kind of make this leap a little bit easier than others. But you want to make sure that you understand how to do this. You need to be able to find partial derivatives and find them correctly for the rest of the semester. All right, so when I do this first partial derivative here with respect to x, the first thing I'm going to pay attention to is where do I have x's in the problem. So here's an x, and here's an x. All right, and so the nice thing about this particular problem, for where my x's are located here, is that all of my x's in this problem are really in separate terms. And so you should remember from Calculus 1, when you find derivatives of functions, you can differentiate term by term. The rule for finding derivatives of sums of functions. So you're just going to find the derivative of each term and add all those derivatives up. All right, so when I focus on this first term here, finding the derivative of x squared times y, remember that x is what's being treated as the variable, and you're treating y as if it were a constant. So sometimes it's helpful to kind of go off to the side and think about some little scratch work about what would happen if you just actually had a constant in there for y. So if you had x squared times some constant like 5, and you might write that as like 5x squared. You might put the 5 in front in that case. And so it's pretty easy probably for you to think about how to find the derivative of that. If you need to do a little scratch work at first when you're working on this, then you can go ahead and do that. So if you were finding the derivative of this function with respect to x, the 5 would come along, and then times the derivative of x squared, you'd use that power rule, where you bring down the exponent and subtract 1. So you'd have 5 times 2, so 10 times x to the first. So the same idea here. When I take the derivative of x squared times y, the y that's being treated as a constant will just come along. That's that constant multiple rule for derivatives. The y will come along, and you can put it in the back or in the front. And then times the derivative of x squared. So you're differentiating with respect to x, so that's the bring down the exponent and subtract 1 rule. So 2x to the first, or just 2xy. All right, and then when you do this second term, the same way, really, I'm just finding the derivative of x to a power times some other constants here. Here I have something that's actually a constant, and then something else that I'm treating as a constant. So the same rule, essentially, that I used here, the constants, when I'm differentiating with respect to x here, the parts that are constant will come along here. So I'll have 6 and y to the 4th. And then those will be times the derivative of my x cubed. So derivative of x cubed, 3x squared. And of course, as you get better at these, you'll probably tend to simplify these as you go. And I mentioned here I had my 6 and y to the 4th kind of at the front and the back, but really the order in this multiplication here doesn't matter. So you might have this term slightly written in a different order in terms of where the variables are, but you need to make sure that when you simplify it, you get the same thing that I get. Okay, on this next term here, I don't have any y's, so this is just like a calculus 1 kind of problem, finding derivative of e to the 2x. So I'm going to have a little chain rule there. I don't just have e to the x, I have e to a function of x. So I'm going to be using chain rule when I find this derivative. So derivative of e to a variable power is e to that variable power, not 2, e to that variable power, and then times the derivative of what's inside that power. So the derivative of 2x is going to be 2. And then when I get to this last term here, this is all just a constant. Remember, I'm differentiating here with respect to x. I've circled all my x's here. And so when I differentiate this last term, that's all just a constant. And so you might go back and do a little scratch work and think about, all right, well, if I just have a constant like 7, and I differentiate that with respect to x, the derivative of that constant is 0. So I don't necessarily need to write 0 here because I'll be adding 0, but you should understand that because this whole term is being treated as constant, the derivative of the constant all by itself is just 0. And then of course you can tidy this up a little bit, and I'll go ahead and put that over here. 2xy plus 18x squared y to the 4th plus 2e to the 2x. All right, so there is our partial derivative with respect to x. Okay, if I want to also find the partial derivative with respect to y, I've got that definition up here as well. And just like the partial derivative with respect to x, you are treating one of these letters as constant and treating the other one as variable. So when I'm differentiating with respect to y, treating y as the variable, and x is being held constant. So when I go back to my original function here, and now I'm going to differentiate with respect to y instead of with respect to x, I need to pay attention to where my y's are, and I'll be treating all the other letters. I'll be treating the x's as constant. All right, so I'm going to go ahead and circle all of those y's here. There's a y, and I've got a couple of y's here. So being careful about that. Just underline them so you're clear about where those y's are. Okay, so when I differentiate with respect to y, remember I'm going to be treating the x's as constant. I'm differentiating with respect to y. So when I find that derivative of f with respect to y, we talked about this notation. Remember those curly things that look like D's del's, remember, indicate a partial derivative. So when you do your work and as you're writing down what you should be writing down, notes as you watch this video, make sure you're writing those correctly. Those are a little bit different to get used to. All right, so when I differentiate with respect to y, this first term here, my y is here, and then x is being held constant. So x squared would also be a constant. So again, you can kind of do a little bit of scratch work and think about, all right, if I just had a constant times y, and I'm going to differentiate that with respect to y, derivative of a constant times y is just that constant, right? So here, our constant will just be x squared. So derivative of this term, constant times y, with respect to y, will just be the constant part, the x squared. All right, on the next term, the 6x cubed will be constant. So when I differentiate that constant times a function, that constant part will come along. And then power rule, derivative of y to the 4th is 4y cubed. And of course, as you get better at this, you might automatically just simplify that to be 24x cubed, y cubed. Right, on the next term, there are no y's in here. So for this next term, when I'm differentiating with respect to y, this whole term is constant. So derivative of a constant is 0. And then this last term, I have y 2 places in this last term here. So I'm going to need product rule on this last term. So hopefully that's not too far gone in your memory. We've done a little bit with derivatives, but we're going to be doing a whole lot more. So I'm just going to do product rule on this last term here. So the derivative of the first function, derivative of y with respect to y is 1, times the second function plus the first function, and then times the derivative of the second function. So the derivative of the sine function is the cosine function, cosine of y. All right, and then again, you can go ahead and clean that up. Be careful about where your addition and subtraction signs are and where multiplication is. So this becomes x squared plus 24x cubed y cubed. You don't really need to write the 0, plus sine of y, and plus y times cosine of y. Okay, so we're going to be doing a lot in the rest of this course, really, but in the rest of the chapter about applications of derivatives. So we'll look at some, what do these mean? Why would I ever find this? What am I going to do with this derivative? That's essentially what we're going to be looking at really for the rest of the chapter. But you can't do anything with it if you didn't write it down correctly. So it's important that you spend some time on this homework and make sure that you can find these derivatives correctly every time. So that means recognizing using product rule when you need product rule, chain rule when you need chain rule, how to treat one thing as a variable and the other letters as constants so that you can find partial derivatives correctly every single time. So make sure you give some attention to this. I'm going to do another example in another video that's a slightly harder partial derivative problem, just kind of the next level, but you might want to practice some of the easier problems in the homework before you go to that next video, just to make sure you've got kind of the basics like we did in this one.